Hello everyone, my name is Joseph Korpela. I'm a graduate student with the University of California, Los Angeles, and I'm going to give a presentation today on implementing Lavatube on the STORM framework. This is based upon research I did this summer with the Open Science Data Cloud's Partnership in International Research and Education program. The research was done at Japan's National Institute of Advanced Industrial Science and Technology. So I'm going to start off with some background information. First, talk about Lavatube, which is a visual programming framework developed here at AST, and it's used for computer vision research. And it provides users with a graphical user interface through which they can put together complex video and image processing workflows. Next, what is STORM? So STORM is a distributed computation framework. It runs topologies on clusters of computers. And then when I say topology, I'm talking about a spout and bolts, with the spout being a source of data, which plays that data out in a streaming data model. And the bolts are different functions that are applied to that data as the data passes through them. In our project, we wanted to achieve two things. We wanted to achieve task parallelism and data parallelism. So the task parallelism is inherent to how STORM distributes these different functions across the cluster. So that's pretty much done already. And then for data parallelism, this is possible with the video data because Lavatube functions often work in an iterative model where they work on one frame at a time. So that's true of many of the functions in Lavatube, but there still are some that we had a little bit more difficulty with running in parallel for data parallelism. And an example would be the functions that merge two streams of frames together. And so to solve this problem, what we did was we used a grouping technique for the frame IDs, in which we did modular division on the frame IDs to assign them group numbers. And any stream of data that's being fed into this topology is going to use the same technique. And so as they send their frames to different bolts within the topology, their frames with the same number actually end up at the same bolt. And that allows us to take two different streams, send their data into the topology to parallelized bolts, and have those bolts receive all of the corresponding matching frames from each and output the correct data. And so now I'm going to go over a quick example of how this would look. So what you're looking at right now is the Lavatube graphical user interface, in which you have a series of functions that are being done to the video being captured from that function on the left. And what it actually is doing is it's detecting this man's face and drawing a circle around it. And so if we were to run this in parallel across the cluster, this is a small example of what it might look like. Storm Nimbus and Storm Zookeeper, those are just running the background. Those are the ones that are actually controlling this cluster. On the left, you have the first worker node acting as the spout, and this is the one doing the direct show capture to take the video and play it out into the cluster, into the topology. And then the following worker nodes are being run in parallel with them doing data parallelism. So you have three instances of each of the next two doing these functions in the video data as it comes through. And then in the end, the video data is put back together and sent to the last worker node that does the last functions on that video. And so for a real-life example, this is something we actually use in our testing. This is the one of our test examples we have, where we have two video inputs coming into the cluster, and it's being recorded out to two different video recorders. And in there you can see that there is a merge of the two video, where on the left you have two video players, and then there's a point where the two streams are actually both coming into that bolt, which will then output its video to the recorder. So this is a screenshot from the user interface for STORM, and this shows when this was actually being run on the cluster. And you can see at the top there's the one spout that's outputting the video data, and then below that you have a number of different functions being done on the data. And to the right of each of those functions, for many of them, you can see they're actually number 4, and that 4 just means that there was 4 instances of that bolt being run in parallel for each of those bolts, with the last 2 only having 1 because the video recorders can't be parallelized like that. And then this picture is just a screen grab from the actual resulting video. So one video was of a hallway, and one video was a dolphin swimming through the water. And we actually had the working video showing the combination of the two once the cluster was done running. So in conclusion, we were able to put together Storm and Lavatube to give us a combination of the two that was a distributed version of Lavatube, which is pretty easily scalable. And that ends my presentation. I thank you all for listening, and thank you.